let's put everything together and take that pixel generation circuit core and place it into video subsystem by creating some wrapping circuit in here so that the processor can actually interact with this core, and a blender so that we can take the background pixels and blend them or pass them as they are to the output in here. And the way we're going to implement it is by creating a wrapping circuit that follows a register map. And here's a suggestion of the register map. As expected, all the registers should be in the right position because the processor only writes into a video core, it never reads from it. And we're going to do something similar to what we've done before, which is basically splitting the register map into half based on the most significant bit values. If it's 0, it's actually doing something. If it's 1, it's doing something else. Mostly it's actually control when it's actually in the 1. So let's take a look at the let's take a look at the control registers here with the most significant to be 1. The first one is just the bypass register. If you set this to 1, it's just a single bit. If you set it to 1, you're technically bypassing the functionality of this core, and you will not see any on-screen display. However, if you put it as 1, you're actually displaying certain things or displaying certain characters within certain tiles. The other two in here are basically defining what the foreground color should be and what the background color should be. For example, you can set this to be green and this is black, and you will create technically an OSD color that creates green characters on a black background. And these are basically the little squares that you can display. If you are displaying characters all over the display, you'll create a terminal that looks like green on black. And the foreground colors and the background colors should be 12 bits because our colors is that way. And again, the OSD character, the pixel generation circuit here actually generates just a single color basically, or single bit. It's either dark or black, or the character is actually white. Basically, it's basically the background or something. And we distinguish between the foreground and the background color in here. Okay, so we're taking a look at the top of the register map. If the most significant bit is 0, what we have is actually the content of each one of the tiles. So these registers, we're going to dedicate a register per tile. The register can accommodate up to 32 bits, but for simplicity, we're just going to say 1 register, 1 tile. So the content of the tile is actually 7 bit for the ASCII character, and 1 bit which will tell me whether that bit should reverse the foreground and the background colors to basically look like it's highlighted. And how do we specify which tile we want? Well, the input of the pixel generation circuit expects something called an XT and a YT, basically the tile X and the Y X, or the Y of the X. And we know that the X is 7 bits, so technically it is actually these bits in here, and the Y is actually the rest 5 bits, which are just these ones in here. So you just concatenate the X of T and the Y of T. Again, that's why we define in the pixel generation circuit, we define that the number of tiles should be multiples of 2 so that we can actually do this in here without doing any calculation whatsoever. So the driver doesn't need it, the hardware doesn't need to do any calculations. Just by concatenating the coupled signals, we can just specify which one. So for example, if you want to do, let's say bit number or tile number, like let's say 13, and the row is actually 2, you can just basically convert these to binary and then just place them in there, and it will take you to exactly the correct register. And then inside that register, you can tell, well, I want to display a certain character, and let's say that character is A. You basically place the ASCII code for A, and if you want it highlighted, you put 0. If you don't want it highlighted, you put if you want it highlighted, you put 1. If you don't want it highlighted, you just put a 0. So let's take a look at the implementation and code for this particular wrapping circuit and everything. So we go to Vivado in here and we see that code. So that code, again, we go through it very quickly. So we have a reset and a clock, the X and Y that comes from the global counter, and then we have the video slot interface, the chip select, the write, then the address and the write data. And here is basically the serial in, or basically the pixel data in and the pixel data out, which each one of them is 12 bits. And then a few signals declarations. Here's the pixel generating circuit, and that's basically the implementation of this particular register map. Again, we just decode signals, so we have a write enable if we're writing to this particular chip, and then based on the value of the address 13, which is the one here, we figure out whether it's actually a control register or actually you want to write a tile value. So you figure it out by saying, well, it's a character RAM if it's actually 0. That's basically the upper ones, or the upper half of the register map. Other than that, it's basically just a register, which are basically the control registers. And I have 3 of them, as you see in here. So I decode based on whether it's 00, 01, or 10, and it's a bypass, foreground color, or background color. And that's what you see in here. It's basically just writing based on these values. I'm writing what I'm supposed to have, and you'll see here it's actually the foreground color and the background color by default. The foreground color, which is basically what color I wanted, is basically a bunch of ones, which is basically white. If you put -1, it's in 2's complements, it's all ones, which means the red and the green and the blue are all set to 1, so it's white. And the background color is going to be 0, which is technically the chroma key. So it'll be just basically white character displayed on whatever background you have. Okay, and that's how you do it. The last one in here is just basically test. It just basically it implements this particular part, which is the blender. Okay, so it asks whether it's bypass. If it is a bypass, you just basically pass the input as is. If it is, the OSD is actually the key color, and let's see what the key color is. The key color is actually the chroma key color. Basically, if it is the chroma key color, you really want just the output to be exactly like the input. You want the background color to just pass by. Other than that, you just take your value from the output of the pixel generation circuit. And that's how you implement the whole OSD core. Then you take the OSD core and you place it within the video subsystem in here somewhere. You go in and you just basically create an instance of it. I believe that particular video core should be somewhere here. So that's right. Here's the OSD core. You just create that instance in here, and that's about it.